All right, so hi everybody. My name is Cameron Pfeiffer here at .text. So in this video, I'm just going to walk through some code that I wrote on basically how to kind of create this kind of role-playing game, this like automatic role-playing game where you can create a bunch of characters and watch them fight each other using structured text generation, which is from a package that .text produces called outlines. So I presented something this like this model at NewsCon 2024. And News has this like very vibrant, creative kind of style. And so I kind of wanted to create something that was a little like that, where we kind of like played around with language models, because I think, language models are this like a lot of people think about using them as like these as like tools and like how you kind of like talk to your data and things like that, and all of that's very important. Um, but as we're seeing in like kind of the image world and stable diffusion, a lot of people are approaching like generative AI type projects from this really creative and interesting perspective. And so one of the things I'm trying to do is kind of show how people can do that with language. And so one of the really lovely things about working with structured text is that you can program with things that come out of structured text that's generated in outlines. So I'm going to walk you through this example, and I'm going to kind of talk about the choices I've made and why I'm doing everything. I'm going to use an app that this company called Modal. So there's going to be some extra code in here that I'll also walk through because I think it's important. Uh, Language modeling is really expensive, and a lot of us just don't have like A6000s with 48 gigs of VRAM and stuff. And so sometimes it's really nice to be able to go use a cloud service like Modal. And so I'll be walking through like kind of how I set up Modal stuff. It's a little clunky right now, but I'm still kind of working on how to do Modal correctly. But let's just kind of get started here. I have a bunch of imports. Um, we're gonna import. Oops, sorry, that was a goof. We're gonna import. Oh, here, let me go to Zen mode again. We're going to import Modal and outlines. Those are going to be kind of the two big packages we're going to use here. I'm going to import some stuff for typing purposes. I'll explain that a little more later. And then I'm going to print out Rich. I don't know if you know this package, Rich, but it's a Python package for just kind of like pretty printing things, like in nice boxes and stuff like that. So I use that a lot here because I love seeing kind of like pretty terminal outputs. This part here, we're going to create an app. So this is like kind of uh, essentially a container for everything that we're going to upload to Modal so that it can run it for us. And so here we've just got Game Master, and Game Master is just like the name of this project that I'm going to put up. And then we're going to pick a language model, and so you can pick kind of whichever model you want. This is essentially a Hugging Face username or organization name, and then the second part is the model name. So Hermes 3, Llama 3.1, 8B, the 8 billion parameter model. So this is a relatively small model. A lot of people could be able to run like a quantized version of this on a lot of commodity hardware or Llama CPP or things like that. So Outlines does support Llama CPP, but generally like transformers and stuff, those inference backends, transformers, VLLM, etc., they tend to perform a lot better um, than Llama CPP does. So we're going to provide some GPU resources here through Modal, and then just kind of like walk through how that walk through using this with transformers. But I really like the Hermes 3 models and most of the Hermes models because News Research has a way of like getting the language models to be more creative and a little more funny and a little more weird. So I try to use like Hermes models just because they're much more interesting, right? Like raw llama models are very like canned and like la da 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 da, and like the Hermes models can really get to some interesting spaces. So I'm gonna experiment with that. This part here is where we expand our, we create an image, and what we're doing here is we're gonna specify the operating system and what the Python version is for that operating system. So we're basically going to go say, go get me Debian, so this is Linux, and use 3.11. .pip install here basically says, please install these packages. So we're going to use outlines, and then we're going to use the transformers package that Hugging Face produces to do the inference. Accelerate here, I believe, is used for GPU assignment. Sentence piece, I think, is a tokenizer package. And then bits and bytes is used for tokenization or quantization, but we don't really use that much this much here, so I may remove that. So basically what we're going to get here is we're going to create we're going to have a language model create artificial worlds. And the way that we're going to do that is specify the shape for these kind of general worlds. So in this case, what we're going to do is we're going to specify a game setting type. And so a game setting type here is just a class that is has string values and is an enum. So if you don't know what an enum is just, you know, type that can be like one of a fixed number of things. So game setting type can be cyberpunk, solarpunk, or fantasy. It can't be anything else. It can only be these things. And so one of the wonderful things about working with outlines is that the language model must choose cyberpunk, solarpunk, or fantasy. It can't choose anything else. Hold on, I'm going to drink some water. You get to watch me drink water. Man, can you believe how good it was that we invented water? Anyway, so this is a class here that's going to describe our world setting. This is the original, this is like the first thing the model is going to generate. So it's going to pick cyberpunk, solarpunk, or fantasy, and everything else it's going to generate is going to flow from this cyberpunk setting. Then we have game setting here. Game setting is another class, this like parent class that contains a game setting type. So game setting has a field setting, which says whether is this cyberpunk, solarpunk, or fantasy, and then a description of that world. So this is like kind of a like what are the major players of the world? Like how does the world feel? And so this is game setting is intended to capture where are we in terms of like a general category of the story, and how does that story, how does the world that story is in seem to feel? So that's what we've got going on here in game setting. Then we have combat skill level. So combat skill level is another enum. And this is just a skill level of a character in combat. And we're going to use this for both attack and defense. But a combat skill level is an enum from low, medium, and high. So language model, again, has to pick either low, medium, or high. It can't pick anything else. That's one of the beauties of working with structured text, is because you can just kind of, you can constrain the language model to output something that's useful to you. Because a lot, you know, language models are just kind of like, la da 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 da, we'll just like output whatever. Or like, if you ever work with Claude, Claude says certainly all the time, which is not what we want. We want the model to say low, medium, or high, because we're programming with this. And we need it to be low, medium, or high, because we have this class and everything. So. And because this combat skill level is just a class, right, the language model will provide us JSON essentially, and then we'll parse it and create a combat skill level when the model runs. We can provide a method here called modifier. And modifier is, you know, if you call this dot modifier on any skill level, you will get a number, 1, 2, or 3. And so we're going to use these for die rolls. So if you ever played any like role-playing game like Dungeons and Dragons or whatever, you know, you get like bonuses to die rolls. So if you have a high attack skill, you get a +3. If you have a low attack skill, you get a +1. So it's a very simple combat system, and you know, we can make this more complicated if we want to as we go along, which I urge you to play around with this, because I think it's fun. You can make some kind of crazy stuff here. And I whipped this together in like an afternoon, so you can make it more interesting. So the next step here is we have skills. And skills are essentially, this is like a super wrapper that contains 2 combat skill levels. And so remember, we have, you know, combat skill level must be low, medium, or high. And so that means we have an attack that's equal to low, medium, or high, and a defense that's equal to low, medium, high. And we can add some simple methods on here. So attack modifier just gets the modifier for your attack skill, and defense modifier gets your modifier for your defense skill, etc. So this is just a way that you can kind of get numbers for whatever your attack and defense skills are. Now, we're going to wrap this up in what's called a character. And so character is a class that contains everything that we need to know about somebody who's in our world. So characters have names. They have a description, so something we know about them. They have some skills, so attack and defense. And then they have health points, which start at 10, and then they descend over time. So, see here we specified those fields. They have string fields like this, and then skills, which we've defined up above, right here. And then we have this health points thing. So I set this to 10, but like there's an alternative way to do this that I think is more correct. I'll update this in the repo, but I think it's something like literal 10. I think that's the correct one, because when you have this equals 10 thing, the language model, when outlines provides it to the language model, this is technically unconstrained for the language model, so it'll just produce some integer that's not 10. And so there's basically a hack that I've done. So for the initialization method, when this object is created, when we put something inside of it, we're just going to set the health points to 10. So this is just kind of like a hack. You can kind of play around with this. And again, you can do all of this because everything the language model is working with here is all just like classes, right? These are things that if you write in Python, you're very familiar with these kinds of things. Like you use these all the time. And so here you can just like write whatever you need to in Python, and the language model will fill it up. Okay, so for characters, we're going to add this attack method. And so the attack method just says, take myself, I am the attacker, and then I'm going to attack an opponent. And what that will do is it will return some number of damage points. So the way that the attacks work is, this is a super simple, like kind of game mechanism. But if I attack you, we both get our modifiers, attack and defense, and we both roll a 10-sided die. I add my attack skill, you add your defense skill. If my attack modifier is higher, I get to deal the damage, or deal the difference. So if I roll a 5 and you roll a 3, then I get to do 2 damage. If the defender wins, then no damage is dealt. So that's all this part does. And then we have take damage. This is a method where if you have damage, you can just reduce your health points by that. And it's capped at 0. So you'll never go below 0 health, but you won't have negative health because that would be weird. And then I have a simple class here called turn. Turn is just a turn in combat, which is just the description of this turn, right? So it's a natural language thing where like Zeke attacks like Tuba Horse and like throws a grenade at Tuba Horse, but Tuba Horse dodges, something like that, right? Like this is like how we take the world of the die roll into the language description of what's happening, because we want the story to feel like something, and we're going to use the language model to help us create something interesting. And we're going to have this game mechanism going on behind the scenes, but you want to read the story and maybe feel a little invested. So turn just contains that, and it's super simple. So then we have a story class, and story is the thing that ties everything together. So a story here contains a setting. That's a game setting, right? That's Cyberpunk Solarpunk Fantasy. It also includes a description of the world. Then we have 2 characters. So the characters are going to be each of character type, and they have skills, descriptions, names, etc. Then we have a reason for the battle. Like these 2 characters, we're going to make them fight, but we want to know why. Like we need some kind of motivation for, why Zeke and Tuba Horse, is that what I said, are fighting each other? And we have some title for a story, right? We want to make this like kind of dramatic and interesting. And so we have here game setting. This part is really important. So you'll see here annotated, which basically is a way for Pydantic types to add some kind of constraint or information to a type. So annotated here says we're going to take our main type, which is list of characters. We're saying we're going to put a list of characters inside of this characters attribute here, but we're gonna include len2, and so len basically is a strict typing method here to say that this list can only have 2 characters in it. And this is one of the really beautiful things about working with outlines is you can just provide arbitrary constraints using any of the Pydantic methods in here. So annotated, len, etc., field, literal, all of those things that you can use to kind of constrain a model into something. I know when I pass this to a language model, the thing I'm going to get is a story using outlines, and a story will contain exactly 2 characters. We'll never get 1 character, we'll never get 3 characters, it won't invent 15 characters by accident. It's not just going to start spitting out random tokens. It will only give us 2 characters because I asked explicitly for that. And then we have the reason for the battle and the title of the story, and we'll see those in a second. And then the final story here is the last class. I promise, it's been a lot of classes. But here, basically, you still need to go through kind of the final story, what happens at the end of the battle, what are the implications of that battle. So the end of the battle is like, Zeke and Tuba Horse have Tuba Horse has blown its last tuba sound. I don't know. And Zeke manages to throw Tuba Horse off the bus, and Zeke reigns victorious, right? So this is like the final description of the story. And then we have implications of the battle. So what happens in the world after Tuba Horse is defeated by Zeke? Well, maybe Tuba Horse like ran the kingdom or whatever, and now there's like a struggle for power, something like that. Okay, so we're gonna start digging here into how I'm actually running this. So this part here is where we actually start playing around with Modal to actually start running to start playing with some of the resources that they have. So I'm going to pass the modal image here. This is a thing we described up above, right here, that contains all the packages and the Debian version and stuff like that. So that actually describes the resources available to our machine. And then we're going to ask for an H100. So there's 4 or 5 methods. There's a few methods in here. So when we see modal.build, this is a decorator function that says run this stuff when we build this container, the first time that this thing is constructed. So anytime you do something that's heavy, like a really expensive operation, like downloading a language model because sometimes they are many gigabytes, you want to run this once. And so calling outlines.modals.transformers will go get you those weights. So this will take a long time running this part here. And then modal.enter, this is a part that's run when you start the container. So every new time that you call this container, all we're going to do is load the weights into memory. So when you call self.model, outlines.modals.transformers, we're going to go get Hermes 3 8b, and we're going to put it in, we're going to use the transformers inference backend, and then we're going to specify this kind of, we're going to say, please put it on the GPU. And then we're just going to store it in self.model. So it's going to be kind of contained to this model object. Okay. So now we have a few methods, make modal.method, modal.method, and these just create each type. So this make story method will return a story. We're calling outlines.generate.json, and that will give us a story. We can also set the temperature here if you like by changing the sampler keyword. Here we're going to use multinomial, which is kind of the standard. Then we're going to do describe turn. All this does is you take some prompt, that's this thing here, and then we're just going to ask for turn. So these are just convenience methods. You can roll these in line. They're like a line. And then same thing with final story. So describe final story, asks for a final story. So I'm not going to spend too much time on the prompts. We'll put the links to the code in the show notes here. But the thing I want you to take away from looking at these prompts is that you have to provide prompting still. So outlines, what it will do is it'll make the model output certain tokens. It can't output tokens that you didn't ask for. It can only follow a specific format. But that doesn't guarantee that the content of those tokens mean anything. So if you don't provide a prompt, it may just like spit out the letter A like 50 times because it doesn't have any information to go off of. It just knows it has to like, spit out A's or B's or C's or whatever, any letter, but none of them actually mean anything without a prompt. So when you're working with structured text, you have to be pretty clear about what you want. And outlines will guarantee that you get the shape, the object that you want back so that you can work with it in your code. But it won't, you have to write good prompts. You can't get around that fact. So just remember that you have to do that. Um, you know, Outlines provides this outlines.prompt thing for kind of templating. So sometimes it's easier to work with stuff. You can just put variables inside of double curly braces, and it will be, if you pass winner and loser to it, it will replace the thing inside of the curly braces with the value of that variable. So in this case, winner name. So, and if you want to do that for yourself, you're just going to create the doc string for this final prompt function and fill it with the information you need. We're adding some new interfaces stuff, so keep that in mind. This part here is what's called a local entry point. So if you call modal run demo.py, Modal will go run the local entry point on your computer. This is code that will not execute on the cloud container that you created. It will run this function on your machine, and then you are responsible for asking the cloud container for, language model calls or hard math or anything like that. So this model type here, remember this is the kind of inference thing that we built that has all these methods like download the model, set it up, like make a story, etc. And so this part here actually does most of the work for us. So if you see model.makestory.remote, all that's calling is outlines.generate.json, and we get a story object out of this. And so we can program with that story exactly as we would any other object in Python. It's not different. It's just a story class. And so this contains all of our characters. It contains a description of the setting, or the cyberpunk solarpunk fantasy. It contains like a reason for the battle and these two characters and everything. It has everything we need to know. So you can print out some interesting stuff here. I like this panel.fit. So panel, it comes from the rich library. So you get these like kind of pretty boxes. And you can add titles and stuff like that. This part here is just going to print out each character and their descriptions and their skills and stuff. And note here, this story, I'm just calling story.characters, right? We define this in this class way up above, right? Where do we put it? Yeah, story.characters. So this is our attribute story.characters here. We can just call that like we normally would. Like we're just writing code with this standard Python object. Because the language model, as of this point, has filled it up with the information that we've asked it for. We described the story and it's created it for us. So we're going to print the reason for battle, etc. We're going to store all of our turns. So what's happened in natural language here in this list. And then we have this loop. So while all the characters are alive, each character is going to take turns attacking the other character. So I'm going to attack you, and then you're going to attack me, and so on and so forth until one of us gets knocked out. So this part just gets our character. This is just whoever doesn't have our current name, whoever is our, whichever character in our list is not me. And then we're going to roll for damage here. Remember, we have that damage method that we defined up above. So I am going to attack my opponent, and then my opponent is going to take the damage that we calculated. And then, if our opponent dies, we're just going to leave this loop. We don't need to keep doing anything. So we'll get back to that in a second. We'll say I am the winner and the loser is the opponent. And then we're going to do a little preparation for like the stuff that we're going to pass to the language model. So action history here basically says story.setting.description. So go give me the setting, like the description of the world, like we're in a cyberpunk future where like corporations run the world and like powerful AIs are rogue and being hunted by, Harrison Ford or whatever. So then we have, is that a data reference? I don't know. Then we have story, reason for battle. So why are these characters fighting? So the language model, every time you call it, because it doesn't have a memory, we're going to keep reprompting it with the description, the reason for battle. And then here, we're basically going to append all of the actions that have happened, right? So this is Zeke punches Tuba Horse, but Tuba Horse dodges. Tuba Horse throws a brick at Zeke and hits him in the head and he gets a little hurt. Deals like 3 damage or whatever. But those are natural language descriptions of what's happening. This part here is action prompt. So this goes into one of the prompts that I defined above using outlines.prompt. And then we're just going to put, we're just kind of going to consolidate it into like all of the things that I need the model to return. I'm describing the, like please don't tell me the numbers of damage that are done, but you should know that like they went from 10 health to 5 health, and your description of the attack should reflect the magnitude of dealing 5 health to someone with 10 health. So that's what action prompt describes, and so prompt here is a string. And then action description, we're going to call modal.describe.turn. And that'll give us, we're calling .remote here. So that's just a method of saying, hey, Modal, please go to the server that I've spun up. And we're going to pass it a prompt. And then here, we're just going to append what we just did to our action. We're just going to take the new action description. So Zeke threw a brick at Tuba Horse. And then we're going to append it to our turns list. And then this part is basically going to describe who attacked whom and how much damage was done, depending on whether there was damage or no damage. So this is just just reporting what happened. So this loop is going to run a bunch of times, and the characters are going to keep attacking each other, but one of them is going to run out of health. So when we do this loop, the main combat loop here is going to exit. And if we get here, we're going to have like winner.name won the battle. So whoever it was, Zeke or Tuba Horse, I guess in this example is Zeke. Zeke took out Tuba Horse. And then we're going to put the history of the battle into this like kind of final prompt. And final prompt here says like, hey language model, like Zeke just defeated Tuba Horse. Here's everything that here's how they've been fighting physically. Like, Zeke threw Tuba Horse like into the glass and broke the glass or something like this. And final prompt allows the language model to create a narrative for how Zeke actually defeated Tuba Horse. Like, Zeke was able to kind of like wrest control from Tuba Horse and heave Tuba Horse out of the bus. And then Tuba Horse gets a headache and has to quit the world, I guess. Don't think about it too hard. And then we're going to pass that to model.describe final story, and that's going to give us a final story object that we defined up above. Then we can print out some information. So let's actually see what that looks like. So I'm going to open my terminal here. I just ran it. It's going to be a little messy, so I apologize for that. But so this stuff, takes a second to run. So I ran it before we started recording. But I want to talk about this part right here for a second. So you'll see this when you use outlines. It'll say compiling FSM index for all state transitions. I'll give you a progress bar. So what that means, compiling FSM stands for finite state machine. And that is the way that outlines actually allows you to shift from token to token. It basically turns off tokens that are invalid for wherever you are in the string. So we can explain this a little more in kind of other videos, but this is a thing that may take a few seconds. So in this case, how long did it take? It took 14 seconds because we're restricting the model to only output certain things. For example, for the story class, the story schema is actually pretty complicated, right? Because we have game setting type and description, which can be anything, but we also have all the characters, and those are strongly typed and have their own like child classes and stuff. So outline still has to construct the shape of the information, the shape of your program, shape of your classes. This is cached, so every time you reuse this, it's stored. So you only have to pay this cost once, um, which is kind of how Outlines is really fast during runtime. And we're bringing this time down all the time. Like Outlines is getting crazy fast, so I would not expect it to stay there for very long. Okay. So the printout here is like a little screwed up, but it's called Neon Shadows: A Cyberpunk Clash. So, in a dark, neon lit city where the lines between man and machine blur, corporate greed and societal decay reign supreme. So, this is just kind of like a standard cyberpunk description, and it talks about how the conflict comes up. I asked it to provide some kind of conflict, and the strong prey on the weak, and the only way to survive is to fight for your place in this unforgiving world. So, this kind of gives us a little bit of like dramatic tension that kind of sets up the general world here. And we actually have two characters here. So we have Arya, who's a skilled hacker who breaks into corporate networks. She has implants and she's like kind of sneaky and stuff like that. So she has a high attack skill and a medium defense skill. So she's good on attack and kind of mid on defense. So she's also kind of a vigilante type. She wants to expose corruption, etc. So then we have Razor, crazy name, is a former corporate security operative turned mercenary. So he's like a hand-to-hand guy, um, and so he's kind of a mercenary. So he wants to go claim a piece of profit for himself, and he's great at both. He's a really strong attacker and a really strong defender. So we'll see how it goes along. Looks like Razor's a tough competitor. Let's see how Arya fares. Okay. So we're gonna do like the kind of the start of this battle here. So we're gonna do as start of a covert mission to infiltrate a powerful corporate data center. Arya and Razor find themselves face to face in an abandoned warehouse. So they're both sneaking around, but they're both trying to kind of retrieve this like piece of technology. I don't like that it's a piece of technology. I can work on prompting to make it more specific so that so that it's actually able to like more precisely pin down the world. But we'll work on it. So this is the first turn. So this is like those are our characters, and then the fight begins. So Arya lunges forward and like attacks Razor. And so you'll know that because this is like a cheaper model, you'll notice some like weird inconsistencies. Like her cybernetic arm strikes Razor with a blistering roundhouse kick. So she's kicking him with her arm. I don't understand that, but like you can address some of this with prompting. You can kind of make this like more interesting by like being more precise. But Razor, with his trained reflexes, managed to catch himself on the overhead pipe, narrowly avoiding the follow-up strike. So this reflects the fact that Arya did 1 damage to Razor. So this was like kind of a light attack that didn't quite that kind of didn't quite do as much damage. And this description does a pretty good job at describing that because he's able to dodge like the second blow. So this part here, Razor attempts to counter Arya's attack with a swift lunge. His metal swords meet cybernetic arm, striking out in a brutal jab. But Arya is super fast and manages to dodge. So this is cool. And this part here is like kind of another thing. So they just kind of keep attacking each other. So Razor can't attack Arya because she's so fast, and but her enhanced body absorbs the brunt of the attack. And so like this is kind of cool because we're getting like a little more attention, and we're kind of like feeling how the story is evolving. Another turn here. Razor does 1 damage. Arya misses. Razor does 5 damage to Arya. That's a big hit. And so, towards her exposed flank. The model keeps saying exposed flank. I've seen exposed flank many times. Um, and I don't know if this is just because I'm like using a cheap model or whatever, but it's very weird that it keeps saying exposed flank. And Razor here wins the battle, which means we have to do another finite state machine compilation because we're moving into we're basically moving into the final story thing, which is a new class, right? It has its own schema, and so we have to constrain the model differently to make sure that it goes into the new shape of the final story thing. So, and apologies for this stuff here. This is just like stuff that Modal spits out. I can turn it off, but I forgot. So, as the dust settles from the intense exchange of blows, Razor sees his opportunity. And his implant rips through her cybernetic body in a vicious arc, and Arya crumples to the warehouse floor. So we lost Arya, the cool hacker person. So pour one out for our homie. And then we're going to kind of look at our implications here. So Razor wins, leaving them behind as remnant, but it's not just the class of 2 skilled individuals. It represents the harsh realities, blah, blah, blah. So this could also be better. You know, a lot of this stuff can be addressed by prompting, but this is how we kind of go through and create a story. So I hope this kind of shows a little bit how you can program with language models, right? So one of the really beautiful things about working with structured text and working with .text and working on outlines is that I'm starting to become more aware of how powerful this stuff is for programming, like working with language models. You kind of take them from these like toy chatbot kind of things to tools that you can use in production systems. Like I can make this arbitrarily complicated. I can have like these huge classes. I can have like, you know, many characters. I could have this huge world. I could like work with context management and knowledge management and all of these things as we go along. And we can do all of that with outlines because it'll always give us objects that we can program with. And so I think that's really beautiful. And I'm really starting to enjoy learning about how you can use structured text to make stuff that's really interesting. So if you liked this, you know, please, you know, try expanding it or playing with it or playing with something similar. So I would personally love to see anything kind of unique and interesting that comes out of people's brains, because I think structured text is a really amazing way of like unlocking the creativity that comes with programming, right? Because programming is meant to be fun. It's fundamentally a creative act. And so I think working with language models is a way to get more creativity available, just because these things are so flexible and so powerful. So yeah, I'm Cameron. It's been really nice talking to you. I hope it wasn't too clumsy.